the last session of testing. As experience shows, majority of you guys can test. Yeah, right. I hope you guys can test. What instruments will you use to test? I'll give you the first hint. You look through it. Visuals, eyeball. Now, what other instruments can you use to test? Say yes or no. Ohmmeter, voltmeter, ammeter, mega. No, the brand name. Can I say insulation resistance tester? Yes.
Yes.
What about the fault loop impedance tester? What about the RCD tester? There we are. So guys, have you guys ever touched them? Have you? Right, you know where to press the button and where to keep your fingers. In the theory exam, they can ask you, when you look at your test instrument, is it safe to use? What will your question be? Check the leads. Correct? When you look at the leads, are you going to check if there's any cracks? Can you confirm that your meter has got the leads plugged in at the correct places? Right? If I say to you the meter is installed in the correct places, then it means you're going to select the right scale. Click, click, click. Can you measure amps by putting it on the ohm scale? Can you measure ohms, put it on the amp scale? Is it important to have the right scale? Right. So all that, if you don't do it properly, 1, you can blow the meter. 2, you can hurt yourself. 3, you might get a dead short somewhere. You guys with me? So be very careful what you do, how you do it, and when you do it. Now you all want to be electricians. Some of you guys got a lot of experience. Some of you guys got about 3 to 3.5 years experience. Those that come from overseas, the test instruments you use overseas is the same test instruments we use in New Zealand. Now please, do not say mega. If I say to you a complex test instrument, it means it's a big box where you put everything in and you select the scale, ohms, impedance, RCD, fault loop, you know with me? But it's important to select the right scale. Now I'm just going to ask a question and I want to see if you guys know these questions. An amp meter. Have you guys heard about an amp meter? What's the internal resistance of an amp meter? Is it 0 ohms or 10,000 ohms? An amp meter. It's very close to 0 ohms. So an amp meter, you cannot connect between phase and neutral. What's going to happen if you put 0 ohms between phase and neutral? It's going to blow. Don't do that. If I give you a voltmeter, is it got a high resistance or a low 0 ohm resistance? It's got high. That means I can't put it between phase and neutral. If you're going to use a voltmeter in series with a line, you're only going to get 230 volts across the voltmeter and your light won't work. So guys, very important, moral of the story is, use the correct meter at the correct place. One of the good things you will have is that an amp meter today is all clamped. So you put it around a conductor and you measure it. It's like a CT. Put it around it, done. Is that clear to everyone? That will be your CT. But we're going to go back to amp meter. An amp meter, you put around it. But if you take an amp meter and you want to measure amps, sometimes if you've got your lead in the wrong place and you put it on amps, your meter will go beep, 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 beep. It will warn you it's a wrong place. So very important. If you use your meter wrong, you're either going to get damaged yourself or you're going to damage the meter, or you might get it short and you're going to damage mommy's installation. Is that clear to everyone? Right. So before you do a test, do you have to ensure that your meter is working? Ruth, I'm not swearing to you all, but have you heard about proof, test, proof? Prove your meter is working on a known source, test, and then prove again. You will get that in the exam. Very, very important, critical. How you do it? On a known source, before and after the test. Why do we prove an instrument? It's to ensure that your meter is working before and after. Is that clear to everyone? Now, why do we test? Obviously, you're going to test to see if there's voltage, or you're going to test to see if it's off, or you're going to test if there's amps, or you're going to test if there's ohms. Now, take a beeper. You know those little induction testers? It goes, brrr. Now, before you test, you go to a motor, you say, look, it's dead. In the meantime, the batteries fell out. As to then you're going to take that tester, you're going to go to a known source, and brrr, yes, it's working. It should work here, but it's dead here. What does it tell you? It's dead. But then you go back and go brrr, again that side, confirming before and after the test that your instrument is working. Is that clear to everyone? Now, guys, how will they put it in a on an online exam? Very simple. They'll say you do proof, test, proof. The two proofs represent checking if there's power. No. Checking if your meter's working. Yes. You see that? They give you right and wrong answers. So guys, learn to read possible questions with answers. Right, when we're going to do a 3000 test, easiest for me, simple. Do you have access to AS Internet 3000? Do you all have it? Did you know that you can take that into the exam? All the testing questions, answers can come from this, except one thing. It doesn't tell me what instrument to use. But you can figure that out, I can hope so. If not, ask your money back. So, the question is, if you read the 3000 book very well, I'm going to ask you a question. Is it true that you do tests while you do the job with the eyes, before you put the jib up, and after the jib is up? Because before you put the jib up, are you going to confirm that the wires are the right distance apart from the electrical stuff? Is that visual? When you're in the ceiling, you're going to check if the cables are clipped. You're going to make sure that it's far away from certain hot stuff. Is that visual? Visual, 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 visual. Right. What's very important, I don't think this will be in your exam, but it's definitely in the regs exam. When you install cables, if there's not ping back yet, you must take the assumption there's going to be ping back installed. So at the end, it's still the sparker's responsibility to ensure that those guys who put the ping bat in does it properly, because if they put ping bat both sides, you reduce the current rating of the cable. You must make sure that they put the ping bat only one side. Otherwise, the cable's going to burn and you're going to have a fire. So the moral of the story is, you do test prior, during, and after everything is connected. How's that sound? Continuously. Now, you always wondered when your boss comes to you with his hands in his pockets, he is more than you, you look what you're doing, and he goes again. You know why he's doing that? He's visually checking what you've done. If there's something wrong, do not feel offended if your boss tells you, what the hell did you do? Why is this wrong? Because at the end, who's going to sign the COC? You or your boss? The boss, the manager, the supervisor. So he doesn't want to put his name on something which is wrong. You guys okay with that one? So guys, when I was apprentice, I was always keen to learn on my mistakes. But I try to make a mistake once and I don't want to do it again. If you keep on making the same mistake, sometimes the boss is getting tired to say to you, stop doing it. He might just go here and say, come, give me $50. You know what I'm trying to come down to. So in the real world, if you do something wrong, can you be fined? Some of you guys have done regs, eh? In the regs, it says you can get up to a $50,000 fine. Your boss can get up to $50,000. You can get individually fined up to $10,000. If you do something so bad, WorkSafe can take you to the district court and you can be fined up to $1 million. So guys, you guys remembered when there was that River Pike investigation? The big cheese of the company was fined $1 million. Can you see where that money comes in? Now, he's got a big fine behind his name, and unfortunately with the river pipeline, some people passed away as well. So be very, very careful what we do. Testing is critical because we don't want to liven installations. Right, it says at the top of AS NZS 3000, precautions shall be taken when we do testing. Now, Act 82 states very clear, you can liven an installation for testing purposes. You guys got it? Act 82. Act 82 also states you can liven it from any supply, from a 10p building supply up to a generator, or at the end from the real supply. You guys okay with that? So, when you're going to liven the installation, are you sure you're going to make sure that nobody's touching wires? Think about this. Your kids, you've got 2 kids, apprentices, working on the lines. You don't want to hurt them, right? Also, when you do insulation resistance test, how much voltage do you crank into the system? Is it 500 volts? Right? So if you crank in 500 volts into an installation, can that 500 volts give you a bit of a happiness? I don't think you guys call it happiness. We call it a shocking experience. So guys, that bit of shock which you're going to receive, if you've got a weak heart, can it stop your heart? Absolutely. So be very careful. You and I sitting next to each other. If you don't know me, how do you know I don't have a pacemaker in my body? Make sense? You won't believe how many young people today have got pacemakers in their bodies. A pacemaker is just to ensure that your heart is beating the right beat. If it drops down, it changes on again and it will bring your heartbeat back to normal. It's a great invention, but the only problem is, if you go to Australia and you go through the customs, it shoots on all the machines. It says you've got some metal parts in your body. But if I put a 500 volt mega through you, you can imagine what's going to happen with that little digital device inside your body. It might stop. And then what happens if it stops? We won't go there. It becomes a silent movie. Right, guys, you got the examples. Now, last thing is, when you do insulation resistance test, if you put 500 volts through a digital device, can you damage it? So is it true that you try to bypass or short electronic stuff out? So I gave you a bit of a background. This is the knowledge you're going to take forward when you're going to do a test. In this document over there, 3019, it refers to something. Now, this is not a regs exam, this is a theory exam. But in 3019, it actually states, when you have got an installation, you only just don't check the wiring, you also check if the fittings are correct. Have you installed the right current rating light switch? You can't put a 30 amp breaker on a 1 mil cable. Make sense? So you must use a bit of a law knowledge as well. Some of you guys know that a 1.5, you're going to use a 10 amp breaker. But where does it come from? The 3000 book. Now that's a regs exam. So it says here that you must make sure that all tests are correct and your fittings are all electrically safe. Good. Visual test. You guys will laugh. What instrument will you use to do a visual test? A mega, insulation tester, a multimeter, or an eyeball? It's in the exam. They could ask you. They just want to know if you know what we're talking about. Eh? Oh, that will be an easy one, but you're going to say insulation tester. Okay, guys, when you do a visual inspection, please make sure that the visual inspection is per the legislation. Visual inspection in the 3000 book says, look at this, 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 look at this. Now, let's do an installation test. Before I'm going to do an earth test, and I'm going to ask you, I'm going to give you an appliance. If I say to you, look at the lead, what are you going to look at the lead? Are you going to look if the plug is okay? Are you going to check if the phase, neutral, and earth is not bent closed? Are you going to check if your lead is not cracked? Are you going to confirm that the lead grip is correct? Are you going to confirm that the brown and light blue doesn't stick out? Hey, the green, brown, and blue, if that sticks out, and you get shocked somewhere, and you were the testing person, you're going to be in trouble, because no primary insulation is allowed to stick out. Now, who of you guys install downlights? You know that in a downlight there's like a little transformer. How long do you keep the red and black out? Well, we say inside, but sometimes it can't because the gap is only that much. If you read the 3000, it doesn't mention that, but it must be as short as practicable, maybe 1 centimeter. They won't put you in jail for that. We had a guy who left it on 10 centimeters stick out. He was fined $1,000. Read the electron. There's wonderful, no, there's sad, false, or testing, or issues people made. So guys, primary installation, you try to hide. Is that all right with you all? Now guys, when you do an earth continuity test, according 3000, there's quite a few earths we can get. Now firstly, let's look through the test. Now guys, what instrument will I use to do an earth continuity test? Are you going to use a voltmeter, an insulation tester, or an ohmmeter? Ohmmeter. Where are you going to test for the main earth? Is it from the peg's end to the end of the conductor, beginning and end? Is that right? Yeah. Now, if I ask you, and this is just a general knowledge question, the main earth wire is 12 meters long, but your multimeter lead is only 1 meter long. Can you have a trailing lead? Have you guys heard about a trailing lead? So, but is it correct to say you're first going to check the resistance of the trailing lead, then you're going to do your test, and you're going to deduct that from that? Happy with that? So they can throw a little question of that in the theory. Remember, it's a theory exam. They could ask you that odd stuff on testing. Now, before I do this, why do we earth everything? A is to ensure that everything is earthed, or is it B, to ensure that the voltage do not rise above a certain voltage? Both answers is correct, but the most correct one is you don't want this metal part to become hard.
Can everyone mute, please?
Yep, I'll do that. So guys, if I say to you, do a earth continuity test, is to ensure that anything which is metal is at the same earth potential. If not, a couple of things can happen. Here comes the general knowledge. We would have covered this in chapter 1 and testing, and then transformers. We touch it on motors everywhere. You want to make sure that your touch voltage do not rise above 50 volts AC. If it does, it can shock you. Guys, if the resistance is not low enough and the fault conditions, there's a possibility that your protection devices will not trip. You guys happy with that as well? What's important about a circuit breaker? Must it trip if there's an earth fault? Of course it must. But if it doesn't, what then? Metal parts becomes live. What does a voltage do? Well, you can imagine what's going to happen. Well, if you don't know, come to me. I'll put your fingers between phase and neutral and you can feel. No, I will never do that. But you've seen it on Google. You have seen it on YouTube. Don't do that. But I bet you some of you guys do have the experience which you would not like to do again by getting shocked. Have you guys been shocked before? Was it a shocking experience? Right, very important. It was a feeling which you don't want over again. All right? Have you guys been shocked badly? Guys, I was shocked years ago by touching phase and neutral accidentally. I was holding the cable. I don't know what was live. I was still a youngster. I would say I was about 15-ish. And somebody tripped over the lead. And you can imagine when somebody pulled the lead, and eventually I got the 2 coppers in my hand. And I was vibrating and doing the breakdowns till that 20 amp breaker tripped. There was no RCD. Right. When I was finished, I looked at my fingers and I saw slots burned into my fingers. Now, I was not a very happy camper, but I survived. I could have died. But anyway, maybe I was still young, played rugby, my heart was good. Luckily, a couple of years later, I'm still okay. All right? Cool. So guys, first thing I want to bring up. Do you know what's a main earth conductor? Be honest. It's a name they give it. And if you don't know, it's a wire between the peg and the earth bar. Got it? Theoretically, they can ask you, which cable connects the peg to the earth bar? Is it a main earth conductor or a bonding conductor? Main earth conductor. Which conductor connects the earth bar to a water pipe? Right. Which earth conductor is inside a cable? Is it a main earth conductor, a bonding conductor, or a protective earthing conductor? They ask you that. Right? Happy with that? Cool. Now, the main earth conductor and the protective earth or bonding earth conductor, try again, the main earth and the bonding earth conductor's resistance cannot be more than half ohm. Got it? Now, half ohm is 0.5 of an ohm. If you get more than 0.5 of an ohm, you must go and check if your connection is tight, or alternatively, make a bigger size cable, because the earth which is in might be the wrong size. So guys, just a matter of knowledge. You know what's the minimum size main earth conductor we're allowed to use? I'll give you a hint. Look at my 4 fingers. 4 mil. Is that right? What's the maximum measure you can get? 120. Right, in 3000, chapter 5, it tells you it can be between 4 mil and 120. Bonding conductor. What's the smallest you can go? Look at my 4 fingers. 4 mil. Right, 3000, 5.6 tells you that as well. Right, I'm going to take this now and I'm going to ask you questions. Firstly, you take your main earth wire and you connect your multimeter between the beginning. Are you guys happy with that? And what type of instrument will I use to measure ohms? Is it an ohm meter, a voltmeter, or amp meter? Right, they ask you that. Now, where do you put the wires? Obviously, the leads you're going to put it in the beginning and end of that wire. You're going to press test. But before we do the test, is it true that you're going to take your multimeter leads and see if you get 0 ohms? Prove. Do a test. Do a prove again. Now, guys, when you measure there, boom, is that okay? See the reading on my meter? Just. Right. So what instrument are we going to use? Ohm meter. If you have to select a scale, you always choose the lowest ohm scale. Right? Lowest ohm scale. To carry on, when you do the test, a lot of your multimeters has got an auto range scale. The meter will decide. Now guys, I'm telling you now, in the exam, they love to ask questions like, what instrument, where do you measure between, and what is the reading, or what scale do you put it? So let's confirm. For a low ohm scale or ohms reading, you put it on a low ohms range and you're going to get a reading. After that, low ohms. Now the reason we say that, and many moons ago in some multimeters, you could choose ohms, kilo ohms, or mega ohms. You could choose the range. It was not auto. And that's where that question came from. You put it on the lowest ohm scale. Right, you do your test. Now, what are you going to measure? Maximum 0.5 of an ohm. Now, what's good about this exam, they're going to ask you, is maximum 1 ohm, 2 ohm, 3 ohm, or half an ohm? Remember, max. Can it be 0.2? Yes. Right, guys? Will we do the test? Obviously, you're going to put your meter on one side and to the other side, you're going to get a reading. Right, all this is defined in my handbook. You'll be able to find it there. Right, but last but not least, is it important, go back. Is it important to disconnect that wire from there? Why do you guys think so? A, because otherwise I can't get a good connection. B, otherwise I can have a loop via the system and back.
You'll be measuring the neutral.
You're actually measuring the soil neutral parallel back. You see that?
Why are you supposed to really measure it when you don't?
Right, we will not touch the MEN link because we're only checking the main earth wire. So I'm going to go back. Oh, sorry, it will come forward. Okay, let me just do this quick. What does it say there? The resistance of the main earth conductor. See that? Right, so we're measuring the resistance of the main earth conductor. So guys, this loop from the back will give you a false reading. Your wire might be broken, but in the meantime, you get a good reading because your soil is wet, your transformer is close by, you're going to get a false reading. So it's possible that this reading you're going to get, that wire is broken, but you get a parallel path back. I'm just warning you what could happen. Right, guys, for bonding, you put it on the earth bar and you measure to any other bonding conductors where it's supposed to go. You all agree that anything which is metal must be earthed. Now, guys, I'm not a person who knows my building codes very well. However, the building code states that if you got suspended ceilings, the bars which keep the suspending ceiling up must be bonded. See this upstairs where you look in the room? Do you know what's rondo? Building code says you shall earth or bond the rondo as well. What size wire? Right, 4 mil or greater, correct. Minimum, right, guys? And again, the same sequence. Where do you measure from and that? Maximum, how many ohms? Half ohm. Happy? Are you okay with that? So, gentlemen, ladies online, you're going to get quite a few questions from this. Are you okay with what I just said? Ohms, low ohm meter, beginning and end, not more than half ohm. Cool. Right, guys, a mouthful just for that 2 tests. Now I'm going to go to the next test. The next test is called the protective earthing conductor. Where is the protective earthing conductor? Is that the green wire which goes from the earth electrode to the earth bar, or is it inside the cable? It's inside the cable. Right. When there's an earth in a cable with phase and neutral, we call it a protective earthing conductor. Happy with that?
Yeah.
How low must that resistance be?
Same.
No. Read what's coming up there under A. Low enough to operate the protection device. Now you guys are going to ask me, Marius, what's low enough? Say that? All right, I'll tell you what's low enough. Right, guys? All I want to do is read what table pops up here. It says here, go to table 8.2. This might be the first time ever someone's going to show you this, but if not, it's okay. You guys will all get there. Now, guys, in my inspector's course, I keep on telling the guys, teach the electricians what to do properly. Show the apprentices. Some of you guys will know. So what I'm going to do now is I'm going to show you how to do this on paper. Right. If I ask you to do it on paper, can I confirm that I've got a red, a black, and a green going from a switchboard to a plug? You guys happy? How low is the resistance for that earth wire? What does the definition say? Low enough to operate the protection device if there was a short to earth. But how much ohms is low enough? Now, look, they can give you the table. Now, what I'm going to do now, you all agree it's a C16 breaker. Can you all see that? You all can see it's a 2.5 millimeter cable. Right, here comes the part which are going to suck you up and spit you out, and you won't know what the answer is. Table 8.2 in your 3000 book states the following. From the far left, your active conductor size. The next one, your earth conductor size. The next one, your circuit breaker size. Then, can you see it says B, C, and D? Have you guys ever seen an acronym in front of a circuit breaker? C type, B type, A type. Look at the top question. Can you all see it says C16 breaker? You all agree we're going to look at C. Now look where my mouse is. Resistance of the earth, resistance of the phase and earth. They did it on purpose. I'm going to sneeze now. And if I sneeze, it tells you this is freaking important. Now, I'm going to do some magic there. So you can focus on one point only. You all agree it's a 2.5 cable. Can you all see 2.5 over there? You all see that? Right. Can you all see that the 16 amp breaker? See there? C 16. Right. C type. What's the resistance of the earth? Maximum 0.61. That is low enough to protect that circuit so that when a fault occurs, the protection device will operate within 0.4 of a second.
What's the 1.22?
Okay, we'll get to that one. Can I just quickly see? I think someone is actually can't come in the class. No? That's fine. So guys, I see you guys writing good answers down in the discussion we have. Well done, Graham. You guys are very active. Great stuff. Right, guys, you all agree that from here to the plug might be 10 or 15 or 20 meters. Your multimeter leads is only 2 meters long. So if I go to the switchboard and I short out phase and earth, and I go back to the plug, you all agree I measure earth and phase back. So if the one is 0.61 and the other one is 0.61, if you add that up, it gives you 1.22. So what this thing did, it's actually thinking for you. How's that sound? Now, I'm going to go back a couple of photos, and I would like you to tell me an answer. And now you're going to look at this and say, oh, golly, I don't know. We're doing a light. It's a 10 amp breaker, 1.5. 10 amp circuit breaker, C-type, C10 amp breaker, 1.5 millimeter wire. So it's this line here, 1.5 10 amp breaker. What is the resistance of the earth wire? Right, well done. The maximum ohm reading will be 0.98 of an ohm. So can you see that phase and earth is the same size? That's why the reading is the same. Now, which TPS earth is smaller than the phase? 6 mil? I'll give you a hint. 1, 1, 1, 1, 1.5, 2.5, 4, 2.5. What size? 4 mil. So over from 4 mil, you see that the values is not the same anymore. See there, it's the same over not here. So as the cable gets thinner, your ohm value is a little bit bigger.
Well, they changed it.
It's always been like that.
I think with the 6 mils now, like a while ago, old cables just like 3 up to 6 mils.
Okay.
So,
Yeah.
Well, all what they did is they brought it in line with the tables. Because you can have it as a 2.5. See there? 6 mil can have a 2.5. Just bring it in line. That's all. Right. Many moons ago, I remember 4 mil was 4, 4, and 4. Your earth is based on the active conductor. We're not teaching regs tonight, but there's a table called 5.1. It tells you what the active conductor is, what the earth must be. There's also a formula where you can work it out, what the earth resistance size will be. Right, guys, so just to continue, you all agree on this picture, it's a C16 amp breaker. The resistance of the earth is 0.61. The ohm reading cannot be more than 0.61 of an ohm. Are you okay with that? Happy? I don't say they will ask you this in the exam. They could. Right? So here we go. I go, press test. Ooh, it's on the border. Got it?
That's a pass.
That's a pass. Now guys, do you agree? Doesn't matter how long the cable is. It can be the first, second, third, or fourth, or fifth one. They all shall be less than 0.6 of a 1 of ohm, 0.61 of an ohm. If it's more than that, well, you're either going to lose connection, or your earth wire is too small. You must probably have to upgrade to a bigger one.
The length is too long.
If the length is too long. Now, guys, you can work yourselves out. Rho times length over A give you your resistance. You all got your formula sheet with you somewhere. Go to the book you've got and go to the front page. Just turn one page over and look at the formula sheet. Right, you go to the
Yes.
middle. Yo,
Even how long the length of the cable?
yes, you go to the formula sheet, and you go to the middle column, and you go to the bottom one of the middle column. It says resistance equals rho times length over area. Now guys, the problem is that rho is a specific resistance for copper. So for copper it's like 1.73 to the power of minus 9, I think. It's a scientific value.
So it's the resistance of the needle.
is the resistance of the copper, which is already predetermined in laboratories. And if you really take that formula and you transpose that formula and you work out length, then you can work yourself back. What is it? But guess what, guys? We as Sparkies, I would love to see you guys have a calculator there and try to work it out. Now, I bet you, do this tomorrow. If you take your TPS 2.5 out of your van, it's a roll of what, 50 meters, 100 meters? Take your ohm meter and measure earth to earth, beginning to end. See what you're going to get, 400 meters. That will be a good exercise. And what you can say, half of it, obviously will be half the resistance. A quarter of it will be that. And you can work out what will give you 0.61. And that will give you the length as well. Isn't that okay? You take 100 meters and you can work yourself back. That is physically. But in this case, a bit different. Cool. Now, if I give you a toaster. Now, this book is not given to you. They expect you to know this. Now, there's a standard called 3760, which will tell you. Now, all Supermans and Supergirls, look at my toaster. If you see inside, that looks like that, eh? So you take your ohm meter, you put it in the beginning and end of your earth to the casing, and you press test. What's the maximum value you'll get? Is it A, low enough to operate the protection device? B, half an ohm? Or C, 1 ohm? Maximum 1 ohm. Do you remember appliances 1 ohm or less? Do you know that the extension need is 1 ohm or less? Now, gentlemen, ladies, this is a question in your exams. They all know you know main earth. They know that you know bonding, but people don't learn appliances earth. Why must it be 1 ohm or less? If the appliance create a fault, protection devices will operate. There we are. All readings 1 ohm or less. You guys happy with that? Cool. Now this is not in the 3000 book. This is in a standard called ASNZS 3760. How do you do the test? You're going from the plug to the end of any metal piece. Please do not go and scratch mommy's toaster and say, now I've got a good earth. Normally go to the bottom, there's a screw somewhere, measure to the screw. All right? 1 ohm or less. You can put it on here. Cool. Thank you. So you guys happy with that? 1 ohm or less. So recap all the earths before I go to the next test. The others, 1 ohm, half an ohm, or low enough to protect, to trip the protection device. Now, a main earth conductor. What's the resistance? 0.5 max. Bonding. Appliance earth. A double insulated earth. Right? An appliance with double insulated hasn't got an earth. Right. What about a bonding conductor? Half ohm or less. Eh? What about the earth from the switchboard to a light? Or a stove? Or a hot water cylinder? Or a plug? Low enough to operate the protection device. Can I confirm table 8.2? Right, guys? So that's your answer. 1 ohm, half ohm, or low enough. So it's either low enough to operate the protection device, or half ohm, or 1 ohm. Is that clear to everybody? And in all that cases, I use an ohm meter on a very low ohm scale. Cool. First test done. 6 to go. Have you guys ever heard about the insulation resistance test? Now, before I do this test, can you take an insulation resistance tester and measure it with voltage on the installation, or must the installation be off? Off, because 500 volts DC and 230 volts AC, apparently they don't like to talk to each other. Something's gonna, what's gonna do that? The voltage or your meter? Correct. A lot of the meters got a fuse in, and the fuse will pop. Imagine you borrow your boss's $2,500 fluke. You know, that big thing. And you plug it in and it goes poof. You know what you're going to say? Ish. So you're going to switch it off, put it back, and say, I haven't touched it. So guys, be very careful.
What are they called? What are they called?
or they call it a complex test instrument.
A complex test instrument.
But the complex just means it's got a lot of
Lots
things
of
in it.
functions.
It's got a voltmeter, ammeter, ohmmeter. So when it's a complex test instrument, always select the right scale. Ohms, amps, volts, or even insulation resistance. Right, guys, so before I do insulation resistance test, any test you do, if you don't test properly and you live an installation, can it kill someone? Can metal parts become live?
Yes.
Can it cause fire? Can it cause harm? Anyway, look at A, B, and C. The answer is there. It's in your 3000 book. The only thing which is not there is death. But you know that's worst case scenario. Right, guys, now you're going to do insulation resistance test. Why do we use 500 volts AC or DC? Right, guys, you guys would have heard, oh, it must be double 230 volts, or it must be this, or must be that. The most correct answer is this. Come back. You guys ever heard about volt peak voltage? What's volt peak? What's RMS voltage? RMS is 230. Divided by 0.707, you get 325 volts. So your test voltage must be greater than 325. Got it? And that's why we choose 500. Now what happens if there was an electronic device in there you're scared to damage it? Then it states you can use a 250 volt tester. Now why DC? Firstly, AC, when you put AC in the system, your needle will go up, down, up, down, up, down. You're going to get a fluctuation. But if I give you DC, you're going to get a constant, accurate reading. Now, all those lovely things is in my books under insulation resistance test. So guys, when I look at my insulation resistance tester, 5 things you must always remember before you do an insulation test. Firstly, make sure that your supply is off. So have a look there at the top left, the supply is off. Got it? Secondly, make sure that your MEN link is removed. Why? Where do you test between when you do insulation test? Earth and phase, earth and neutral. Only. You never ever test between phase and neutral, except if it's just a loose piece of cable. If it's a loose cable, nothing is connected, you can do an insulation test. But if one side is connected to the house, you can never test it because you're going to damage stuff. So you test between earth and phase, earth and neutral. Now guys, earth and neutral, if your link was in, it will give you a fault. Make sense? Next thing, you must always remember to disconnect your main neutral. Because if you don't, you're going to get a short between neutral and earth via the start point of the transformer. Try that one day. Test between earth and neutral. You get a short. When you disconnect the main neutral, the fault will go away. So what you're doing, you're testing between earth and neutral to your neighbor, to the other neighbor, to the transformer. Have a look. You guys will pick it up. Some of you guys will wonder, oh, is that why I always got a short? Sorry, you guys don't test. You guys test, guys? I hope so. The next thing, unplug all mommy's toasters, kettles, irons, and also the TV and VCR because you don't want to damage them. And if one of them has got a fault and you do a test, your instrument test will give you a fault reading. So then you say, there's something wrong with that plug circuit. Meantime, it's mommy's dodgy toaster. Right? All right, guys, and very, very important, all the switches must be on. So you must make sure that the light switches are on, otherwise you do not check the strap wires. You must make sure that your stoves are on because it's form part of installation. You must go to the heater towel rail and switch it on because otherwise you never check the switch wire. Is it true that the switch wire goes from the switch to the appliance? If you don't switch them on, you don't check that wire. So there we go, and we're now going to do a wonderful test. We're going to do insulation resistance tester 500 volt DC. Why 500 volt DC? We must ensure that our test voltage is greater than 325. Volt peak. If you don't know how to get volt, take your calculators and say 230 divided by 0.707. Have you guys ever heard about 0.707? That gives you peak voltage. Right, to carry on, why DC? I told you guys earlier to get an accurate reading. Right, guys, I give you all the possible things they can ask. They might not even ask all that. They might only ask you what instrument will you choose. They might tell you only megohm scale. They might tell you what's the maximum test. How will you do the test? You do it one on earth, one on phase. One on earth, one on neutral. And you press test. Once you press test, all your readings, see there's one between phase and neutral, and there's one between earth and phase. Just earth and neutral, earth and phase. See that? Earth and neutral, earth and phase. And all readings shall be greater than how many megohms? 1 megohms. But what happens if there was an element in the system, like a stove or hot water cylinder? Right, we don't, because it formed part of the element, it formed part of the stove and element, or hot water cylinder. We do a test from the switchboard to everything. And that can go up to 10,000 ohms. Have you guys ever heard about 10,000 ohms? Or 0.01 megohms? Right, here comes a question. Guys, gee, I don't know about you guys. That is the Bible of electrical workers. That is when you were a kindergarten kid or student, when you went to primary schools, you had to read the first couple of letters of the alphabet, A, B, C. This is the ABC of testing. You must know this. 1 megohm or 10,000 ohms. Otherwise, you're going to keep on coming back, or you might pass this exam, but you're going to burn down 20 houses. Is it important to do testing properly? If you can't test, what are you going to do? Ask your boss to show you. You guys are filling in test sheets for your apprenticeships. Make sure that you do your testing properly. Because we have situations where people put stuff in and then we get complaints later. The trainee doesn't know what the hell is cooking. So please make sure you can do your testing properly. To recap, what instrument will I use to do insulation resistance test? IRT tester, insulation resistance tester. If I give you the multifunction tester, you know that big instrument, you just make sure that you test megohms. Take it to insulation test. How many volts will I use? 230 or 500 volts? AC or DC? Right. Now when you do a test, are you going to test between phase and neutral?
Yes. No.
Phase and neutral? No. What can happen if you test between phase and neutral? A, nothing, or B, damage equipment? Right. All your readings shall be greater than 1 megohm. Is that correct? Or, if you've got an element in, greater than 1 megohm or 10,000 ohms. Right, guys, please make note that 10,000 ohms is the same as 0.01 of a megohm.
So what's all the situations that you want to do this?
That one there.
Wow, just the whole insulation resistance.
Well, the whole house. Because you want to see if no cables are damaged down to earth.
So that's the only reason you do that, to see if there's damaged cables.
To earth. Because when I live on it, I don't want metal parts to become live. So that's why you do the integrity of the insulation. Checking the integrity that no metal parts will become live. Right, guys. Now, here comes a multi-million-dollar question. Why can't I use a 9-volt battery to do this test? Why can't I take an ohm meter and measure between earth and phase with a multimeter on the ohm scale? A, because the multimeter is too small, or B, it's not 500 volts. How many volts is the minimum we said? 325. Your multimeter might only have 9-volt battery in it. Is that enough pressure? No. So it will not put a signal through from the one metal through the copper to the cable. It will not pick that up. You know how many times I've seen students take a multimeter, they measure between earth and phase and say, look, it looks good. Yeah, right, everything looks good. Right, guys, when you see an instrument which got like a little surge arrestor there, that alarm bells will go off and say to you guys, right, when you see this, You cannot use 500 volts. You're going to use how many volts? 250. Right, guys? Everything is the same. What will 500 do to that part of the installation? Damage it. Right, guys? Very important. All readings is the same. The only difference is we'll use 250 instead of 500. Now, guys, this is written in the 3000 book. Now, when you open the 3000 book, it does state 250 volts for any MOVs, metal oxide varistor. A metal oxide varistor is the type of device. As soon as the voltage goes above a certain predetermined value, it will derive and it will actually short it out and it will blow. So that LED, when it starts glowing and it goes dead, it's over cadovers with that.
But don't you need to stress it above 325, so wouldn't it be inaccurate?
No, for that device, it's okay. Only for certain devices. It's not your whole house, it's only for certain devices in your house.
What's some other devices?
If you take a computer and you don't want to test it, earth to phase, earth to neutral, you must probably use 250 volts. Extra low volt.
Insulation resistance on the actual computer itself.
Yep, because it's earth to phase, earth to neutral. But it will warn you. If that warning is not there, we always use 500.
So the insulation resistance test on the computer is to make sure that no metal parts will become up.
Yes, correct. Now guys, never between phase and neutral. Earth to phase, earth to neutral. If I give you a kettle, you first check the earth, then you earth to phase, earth to neutral. Happy? Now guys, this insulation resistance test I'm talking about, do you all agree we do it while the installation is dead? Right, cool. When I give you a toaster and you look inside, do you agree you're going to test between earth and phase, earth and neutral? Happy? Now, there's one very important thing you have to do with all appliances. Look what's going to happen with that switch. Because otherwise you do not test the switching wire. You switch it on. A lot of the appliances, you can't. You have to keep your hand on the on position. But now we go. We're going to take a tester and we're going to put it across earth and phase. And that's the same test. A 500 volt insulation resistance tester. We test between earth and phase, earth and neutral. And all your readings shall be greater than how many megohms? And if it's an appliance with an element in? 10,000. You guys happy with that? Now guys, my question is, do we call this a test on a non-live installation? It must be dead. If it's not dead, you can imagine what's going to happen with this lovely little insulation tester. Right guys, I just want to take this to your attention. Can you see it give you a 1 dot gap? A lot of instruments have got different ways, but that will tell me it's infinity. Greater than 1 megohm. Have you seen that before? It's just another way how some instruments will give it to you. Some of them will say 999. Have you seen that? Some of them will say greater than 1. Some of them will just say that. That tells you it's infinity. But wait, there's a little bit more. If I ask you to do a leakage test, we call this a live test. Now, I bet you've done this before. First test you do, you first check the earth. What is the maximum ohm reading of the earth? Is it 1 ohm or half ohm? Appliance, 1 ohm. Can't be more than 1. Can it be 0.3, 0.4, 0.7? Yes. What about 1.1? No. Right, so here we go. I'm going to take my special tester. I'm going to put it across the earth. In other words, I'm going to measure current. So you liven it. You switch it on. Don't touch the kettle. You're going to get shocked if there's a fault. And you measure the current in the earth. Guys, a lot of you guys can't tap into the flex. So you must probably will have your own little test lead. Phase, neutral, earth. And you put your clamp meter around the earth. If I give you a class 1 appliance, all readings will be 5 milliamps or less. The current. Sorry, a clamp meter Class 1 means there's an earth connected. The class 1 cannot be greater than 5 milliamps, the leakage current. If I give you a class 2 double insulated one and you put it in the sink top, you plug it in, and you measure the resistance of the current in the earth, it shall not be greater than 1 milliamp. Now guys, I know for a fact that has been asked in the exams before. So what is the maximum current allowed to flow in a class 1's earth? 5 milliamps. Right, now I'm going to ask you guys this. Have you guys ever heard about a PAT tester? You know what's a PAT tester? What does PAT stand for? Portable Appliance Tester. It's a special tester where you take your plug, you plug it into that tester. The tester is plugged into the wall and you press test. It will check the ohms and it will check the insulation resistance and it'll tell you if it's a pass or not. And what it does, what you don't know, it actually measures if there's any current flowing in the earth. If it's no current, it will tell you pass. If it's fail, it means it will pick up current in the earth. Happy? Mouthful, eh? So what's the maximum current? 5 milliamps for class 1 appliances. For class 2, 1 milliamp. Cool. It's a real mouthful. There we are, 5 milliamps. Maximum 5. If it goes any bit more, mommy's going to get a bit of an afro. Right, there's my little dodgy lead. Some people call it the suicide lead. So can you see that I put my clamp meter around the earth and I'm going to test. So I plug my kettle into that and I plug that into the wall and that will measure the current. Now we find out that that's an old lead we used to have. Now we're running double insulated conductors from a plug to a lead and we make up our own little short lead. Now guys, this rule is only applicable to appliances. All right? Cool. Are you okay so far? So we did earth continuity, insulation resistance. Now polarity. Come on guys, it's only 4 more to go. We're nearly there. Have you guys heard about phase is phase, neutral is neutral, earth is earth? Have you guys ever heard about main cables? Where's the main cable? Where's it normally? From the point of supply to the switchboard, correct? Where is your sub-mains? Is it true from the switchboard to another switchboard? Where is your sub-circuits? From your switchboard to the end of the plug. Switchboard to the light. Switchboard to the stove. Is that right? Cool. What is that? Can you see there are 3 wires coming in? Now, yep, that's a point of entry. My question always is, if 3 wires coming in, red for the stove, red for the hot water cylinder, red for the phase, and a black for the neutral. But can you see the conductors they use is all black in color? How easy it is to swap conductors around? Easy. Right, we're going to check if that polarity is fine. Now, in a dead condition, it's actually quite easy. You take your meter one side and you meter to the other side and it rings out. Beep, beep, beep. You know where it's beginning and end. That's easy. If I give you a 3-core cable, you just spell out which one is the beginning and end. You know how to do that? Right, but if it's live, it's a different thing. But when it's live, you must know how. They're going to ask you this. Now, if I give you a sub-circuit, have a look at that photo, it's okay. I'll give you a hint where to look. There is a black one coming in and there's a red one going out. Over here, we've got a red one coming in and a black one going out. Can you see they swap the polarity around? Ish. There's green connected to blue, even bad. Anyway, big problems in this circuit. Anyway, good. Right, guys, what about appliances? Do we agree that phase is phase is phase, neutral is neutral, and earth is earth? If we swap phase and neutral around on an appliance, can the kettle still work? Absolutely. But which conductor do we switch on and off? The phase or the neutral now? Neutral. So if I switch a neutral off, do you agree that the inside of the kettle is still live? Absolutely. So small things like that. Right, guys? And the last thing is, if I give you a multi-phase system, It's very important to know that red is red is red, white is white is white, blue is blue is blue. In other words, the phase rotation is the same. Have you guys ever heard about phase rotation? You know, when you take a little motor, it's going to go clockwise or anti-clockwise. Now, you test the direction in the beginning, switchboard, and further down. I'll show you this now. So look at this installation. Can you all agree phase and neutral are swapped at the plinth? Now, a couple of years ago, an inspector did it. Electrician didn't check. The homeowner died at West Auckland. Who can remember that?
Yeah. You got
Right.
stuck in a water pipe.
That's right. So guys, what is the consequence if that happens? You all agree metal parts will become live. Because you put 230 volts on the metal. Look, you put the phase straight on the neutral, connected to the earth, and all metal is live. Now guys, what do you think can happen if metal parts becomes live? Do you agree that it can be a shock? Can it cause a shock? Can it kill someone? Of course. Can it cause a fire? Yep. Can appliance still work if you swap phase and neutral around? I would say yes. Can your kettle work if you swap phase and neutral around? Yes. What conductor do we switch? We switch to neutral. Now, what's very, very important? Can you see that on my picture, there's a service fuse? The fuse in the plinth. Will the fuse blow or not? No. Right. Interesting. I'm going to put my oh shit. I'm going to put this here. Phase goes in all the way through the soil of the transformer, all the way back. See the soil? That soil resistance is so high that you're most probably going to get maximum of 10 amps flowing through there. So will 10 amps blow a 63 amp fuse? No. There are line companies across New Zealand. If someone live an installation and they don't do the test and polarity swapped, what happens with that linesman? Gone, fired. They don't get second chances. So that becomes bread and butter. You guys check polarity all the time. So if you don't check polarity, what happens? Metal parts becomes live. Guys, do you think that ever happened before? A lot. Swapping polarity around. See there? Now my question is, now because this is live, there's only one way to do it. You use yourself a remote earth, a trailing lead, and a voltmeter. What voltage are you going to measure when you touch metal? Didn't I say metal part becomes live? 230. Right. Independent earth, 230. Well done, Vincent. What are you going to measure between earth, independent earth, and the neutral? 230. What are you going to get if you measure between earth and the phase? Well done. You guys are writing good answers down. So my question is, when you see that, straight away alarm bells, boom, 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 big problems. Guys, when that happens, people touching metal parts in the building is going to get a bit of a tinkle. Some of them are going to get a massive tingle. And guys, worst of all is people can die. Be very careful. Now, the only way to fix this, to get an inspector out to swap that around. And that happens a lot. Yes, you're right, Graham. Now, if everything is fixed, look what it says here. If no transpositioning is being taken place, what are you going to measure between earth and neutral? Independent earth and earth. Independent earth and neutral. Independent earth and phase. 230. Now, I want to sit back, relax, and tell you something interesting. You will get questions like this. If there was transpositioning, you're going to get 230 to the wrong areas. If you're going to get 0, 0, 230, that's what you want. You don't want 230s between two different places. Is that clear to everybody? If there's one test you must do, it will be this test. All right? Because if you're not going to do it properly, there's going to be a big shuffle. Right, guys, if I give you a sub-circuit, you all agree to ensure that earth and phase are swapped. Can you see that? Earth and phase are swapped. Will the toaster work? No. What's going to happen with the toaster? It's going to become live. And if it becomes live, can it kill someone? Can it have a shock? Absolutely. Right, guys, can it cause fire? So they can ask you scenario questions. Now, guys, that is if phase and earth are swapped. What about if phase and neutral are swapped? If I swap phase and neutral around, see there, phase and neutral are swapped. Will the appliance still work? Which conductor do we switch now? The neutral, right? If you swap the neutral, do you agree that the inside part is still live? Right? I think.
Only to immediately.
Yeah, but okay, this is just an example. I should have put the link in, but you're right, 100% right. But my question to you guys is, if phase and neutral are swapped, it's very important to ensure that if polarity is swapped, you're not going to scratch inside any appliances or fittings. Now, before you do that, as a Sparky, do you check that phase is phase, neutral is neutral, and earth is earth? What do we call that test? Insulation resistance test or a polarity test? Well done. Right, guys, a couple of things I want to ask. Have you guys ever heard about the Edison screw lamp holder? Do you all agree that the end over here is the phase and the side is called the neutral? Well done. Right, guys, have you ever heard about three-phase socket outlets? Right, we're going to do that now. It reads there, all fixed socket outlets for multi-phase supplies shall be connected so that the phase sequence is the same throughout the installation. Now, I've got a problem with that. Many moons ago, people never do it. Sorry? Split neutral. That's regulation. So guys, if you're an inspector one day, you're going to check the polarity at the plinth. Happy? And you're going to tell the sparky is clockwise. The sparky will go and the switchboard and will check, yep, it's clockwise. Guys, there's no rule to say clock or anti-clock. The main thing, what did the book says? It must be the same right through. Right, then the sparky walk through the building, clockwise, red, white, blue. Clockwise, red, white, blue. Clockwise, red, white, blue. Clockwise, red, white, blue. Uh-oh, and red, white, blue. So guys, what are you going to do with that socket number 5? Change it to that you're going to swap the two phases back. Where do you change the direction of the motor? On the plug or in the motor? In the motor. Because you can't change the plug, because then the whole sequence is wrong. Do you all agree that clockwise must be everywhere? Absolutely. Happy with that one? Right. Only about 3 to go. Not much. If a circuit's correctly connected, your earth do not carry current. Your earth only carry operational current. Guys, another example. If your earth do not carry current, then it means the system will work. Your earth is designed to operational current only. I tried again, fault current only. If earth carries current and you accidentally do something wrong, metal parts can become live. Now, doesn't matter where you go, your earth is only carrying fault current, not operational current. Who can remember all the days we used to have an MEN board, a DB board, and have you guys ever heard about a link switchboard? A link board was a DB with a link in it. Now, think about this. If 10 amps goes in a phase and you have no link, neutral will be 10 amps. How many amps is on the earth? 0. But if you've got a link in it, you can have 10 amps in the phase, and it's possible that you can have 5 amps coming back between neutral and earth. Now, in that condition, your earth is carrying operational current. You're breaking 8381A. And that is a fault, because this regulation, this standard, is cited in the regulation. And you shall comply to the standard. Right, guys? Have you guys ever heard about an impedance test? Only 2 more to go, and then we can have a smoke break. So, very important. What is an impedance test? When do we do impedance test? Do we do it dead? Do we do it live? I'm going to answer all your questions for you. Live? Can I do it dead? Yes or no?
No, you can't.
Tonight I'm going to show you can. Right, firstly, what is 3,839 states? 839 states. You do a fault loop impedance test only on sockets, not on RCD. You don't have to do it on lights, you don't do it on the stove, you don't do it on the hot water cylinder. You only do it on a plug which is not an RCD. Because you want to make sure, according to 5.7 of 3,000, if there's an earth fault, all sockets must operate within 0.4 of a second. Can you remember 0.4 of a second?
Yeah.
What trips faster than that? A circuit breaker or an RCD? RCD. RCD is 0.3 of a second. Right. So guys, if you read through this, you must keep your MEN link in. Everything must be normal as are operational conditions. Then we read further. The impedance test can be done live or dead. If you read A, dead. If you read B, live, where the supply is available. If you read the note, number 3, if you do an impedance test on a circuit where there's an RCD connected and it trips the RCD, your circuit is okay. Because is it true that an RCD must operate faster than an impedance tester? Example, 0.4 of a second versus 0.3 of a second. Cool. And here we go. Let's check live. Guys, I'm going to go to a circuit where there's no plug. Now, firstly, if you're an inspector, is it true that you're going to check the switchboard? Because remember, that is also an impedance test. And here we go. We're going to do a test, and we're going to test from the earth all the way to the transformer and all the way back. There's your impedance test. Your tester will give you a voltage. Happy with the voltage? Now, I want you guys to take out your calculators. At the switchboard, type in 230 volts, voltage. Now you're going to divide it by the ohms. The ohms is 0.98. Divided by 0.98. So it's 230 divided by 0.98. 230. How much amps are you going to get? Right. 234 amps. So guys, if you would have taken the voltage divided by the amps at this switchboard, 234 amps is going to flow here. That is your PSC, your short circuit current. Now guys, when you're going to choose a breaker, you're going to ask you 3 things. Will that current trip the breaker? Number 2, will the breaker trip safely? In other words, is that within the limits? And thirdly, the impedance you measured, is it less than whatever the table shows you? Now I'm going to give you an example. You all agree this is a switchboard. If I give you a plug, can you see that I can plug it into the plug? Your meter will give you a voltage. Your meter will give you an ohm reading. And then you're going to work it out. What do we call that? Is that your current or your prospective short circuit current? And guys, be warned, in a theory exam, they can ask you to work out the prospective short circuit current. They can ask you to take the voltage divided by the impedance. If the voltage is 233, have a look there, 233. That voltage we call measured voltage. You can't just say 230. It's real voltage, because voltage will fluctuate all day, every day. So there we are. We go and we say to ourselves, will a 16 amp breaker trip if I put 237 amps through it? Yes or no? Cool. Will the breaker trip safely? In other words, can this 6.8 kA, so this breaker will only trip between 16 amps and 6,000 amps. Will the breaker stop that safely? Absolutely. Because remember, only 200 amps or 237 amps is going to go through the breaker. If it's more than 6,000, you can stand there, I'll be gone long ago, I'll run. So sorry?
What, so much to turn it off?
So the question is, if this was 7,000 amps, that breaker is going to blow up if there was a dead short. So you must always make sure that your short circuit current is within the limits. If not, you have to go buy one with a bigger KA rating. All right? Great. And here comes the third question. If I ask you, go to table 8.1 and 3000, you have to tell yourself, right, if the circuit breaker is a C16 amp, C-type, what's this value in the middle? Is my impedance I measured less than 1.92? That tells me the protection device will operate within 0.4 of a second. If you measure 2 ohms, can you see 2 ohms, it's out? Then you've got a problem. Then you've got 2 ways to fix it. You're either going to use a B-type breaker, or you have to go one breaker smaller size. Otherwise, I've got very bad news. You're going to replace the cable, put a new cable in. You guys with it? Right. Guys, we call this the live impedance test. Now, question again to you all. If that's also a pass, Chappie is very happy. Right. So before I do this test, you all agree impedance test is there to ensure that if a fault occurs, the protection devices will operate within a certain time. Secondly, it will trip. And thirdly, it will trip safely. It's an important test, eh? But we only do an impedance test on sockets which are not on RCD. Right, let's recap. What instrument will I use to do impedance test? A voltmeter, ammeter, or impedance tester? Right. I just proved to you that impedance tester can be done live. Now let's see if we can do it dead. Right, guys? I think the dead one you guys know. Have you guys seen this picture before? Right, you take your ohm meter, you measure between earth and earth, and you're going to measure between phase and phase. Got it? And the resistance of earth and earth, phase and phase, must be less than table 8.2. Now, it is very important that your phase and your earth is less than that 2 values. Or alternatively, together, less than 1.22. But when you do this test, and if it is, then you know your impedance test is okay. Guys, we call this a dead impedance test. Now, can you do this test on a circuit which is with or without a RCD? This test we can do with or without a RCD because we're not live in the installation yet. So you all agree, you can go to every plug circuit, phase and phase, earth and earth, neutral and neutral, and boom, next one, phase and phase, neutral, neutral, earth and earth. Guess what you're doing? You're doing actually an earth loop impedance test as well. Happy with that one? Right, so we call that a dead impedance test. Oh, and the last one is most probably one which is the only test you'll do on an installation where you need a voltage. What voltage do you need to liven a plug? To 30 volts. So we're going to liven it. 3,008,310.2 states. And if you go to regulation number 24 and 3,002.6 states, we can only use type A RCDs. What's the difference between a type A and a type AC? We did that when we did protection. We'll do that next week again. A type A means it operates against AC and pulsating DC. Can you see this symbol here? It's AC and pulsating DC. It's called a type A. Now guys, you're going to get this symbol in the exam. They're going to ask you, is it a type A or type AC? What's your answer? Type A. Now guys, a type AC only has an AC waveform. You'll get this in 3002.6. Guys, this pulsating DC, can you see it's on, off, on, off, on, off. Very important. Now, to recap that, have you guys seen the two waveforms? Which one can we use in New Zealand? Can we use that one? Can we use this one? No. If I give you two breakers, A and B, which one can I not use? You all agree we can't use that one. Why? It's banned in New Zealand. We can only buy the second one. Now guys, if you import any Australian fitting like a caravan or a boat which got power on it, you'll see they all come to New Zealand with a AC only. Then what we need to do, we have to change it. You guys happy with that? Cool. Right guys, when we talk about RCDs, do you know the times in which RCDs must operate? 30 milliamps?
30 milliseconds.
300 milliseconds. If you up it 5 times, it becomes 150 milliamps within 40 milliseconds. Where will I get all that? Regulation number 24. All the times that are in there. Last but not least, for testing, remember to put the date in the switchboard once you tested it. It's always good because insurances will check it. Now, I'm an inspector. Do you know that inspectors must go to a database and type it in? So there's one option, I can go to the database. But guys, you can go to the database and all entries only started around about 2010. What about before all that? It's going to be very hard if the date's not in the switchboard. But there's a very clever way. And the clever way is this. You walk around the house, you look in the ceiling, and you look at the top of cable. Firstly, could you remember years ago, no, this is before your time, you used to have a neutral earth bar with no link. It was just one bar. That tells me it's a 1960 type of house. In 1992, they decided to take the atom and they split it. Oh, sorry, the neutral bar and they split it. Who split the atom? Mr. Rutherford. Right, who split the neutral earth bar? Well, the EWRB decided. So if I give you a neutral bar, earth bar, and a split, so you'll say, oh, well, that could be after 1992. Now, if you go to a house and it's only fuses, then you know it's prior to 2003. After 2003, RCDs came in. You see that I can start looking at certain things. If I look in the ceiling and I see this plastic cable, it looks like material around it. Have you seen them? Well, that also tells me it's the 70s, maybe early 80s. If I look at TPS and I look at the phase neutral earth, there are times that the earth is only copper, there's no plastic around. That is also 70s and early 80s. So guys, that is how you broaden your knowledge and start knowing what's in and when out and whenever to do it. Any questions? Right. So let's have a smoke break and we shall start our revision after that.